Thanks for having me. Pretty much one of my first talks, so bear with me with this one. So about me, I'm Jess Smith. I've been using PHP since 1998, when I was in secondary school. Originally in Gloucester, worked for a company called Fast Hosts, and I now work for DigiCert as a senior principal engineer, and I love LAN parties. What I'm going to cover in this talk is what exactly observability is, what OpenTelemetry is, and how we can use it. And I'm going to also do a live demo of just adding it to an application while we're here, just to prove how easy it is to do. And then sort of the next steps for you. So going forward, what is observability? Who uses observability tooling in their job? Yeah? What tools are you using?
OpenTelemetry.
Excellent. Brilliant. Nice. Where are you sending the data with it? What?
To Prometheus.
Yeah.
And various other things from Grafana.
Cool, awesome. Hopefully none of this is new to you, and feel free to correct me on things as we go. But yeah, so observability it's getting an understanding of your application or service by observing and measuring its outputs. And that's pretty high level, but what does it actually boil down to, and why do we want it? So it's great to allow us to detect problems. So we're all used to log files and check through log files for problems. Observability takes that a step further. It helps us troubleshoot problems, it helps us track down issues in our applications, and it lets us identify where any bottlenecks might be in anything that we're working on. So logs. We're all used to logs, PSR3 logging standard, monolog, and centralizing logs is something we've done for years, sending it off to Splunk, getting Logstash to collect it using FileBeat and things like that. That's pretty standard. We've all probably done that. That's pretty normal. The next thing, though, metrics. So you mentioned Prometheus. They're our key performance indicators. They give us quantitative things that we can measure a system on. And if you can measure it, then you then know what to improve on. So for typical applications written in PHP, we care about things like response times. We care about exceptions. I like doing stuff like tracking login events and other events in your application, so sales and such. And metrics are really useful. And we probably use those. And finally, and this is the nice one that people want to have and a lot of people don't, is tracing. So being able to see from a request coming in, the path it's taken through the code potentially, different things it's hit, events that have occurred. If you're using microservices or calling other services, being able to actually see in those traces the other services which are being called, and potentially even follow the request through those. Traces are a really powerful part. So those three things are generally the three pillars of observability. So logs, textual narrative of what's going on. Metrics, quantitative data. So your exact measurements that you can measure. Traces, visualizing the flow of a request. But the key thing with observability, which is more than just centralized logging and just getting this in, is the context around it. You're able to tie everything together. So from an exact request coming in, what are the log entries that resulted from this? What was the path through the code? What happened? What events occurred? What was the performance at this point when this was running? And it's that context which provides so much power and so much help when running any applications. So what tooling can you use for this? So there's quite a few self-hosted options you can use. So Jaeger is great for traces and visualizing those, along with Zipkin. You've got full sort of platforms like Uptrace, OpenObserve, Signals, which all provide all of this for you, and it's stuff you can self-host on your own. But there's also the software as a service options. So Honeycomb is huge, it's a great platform, and I'll show it a bit later. Datadog, really popular, they're great. New Relic, some of you may have used them before for the APM monitoring in PHP with their extension and getting that through to their platform. Splunk, all the cloud vendors have their own, like AWS CloudWatch and X-Ray as part of that. So those are the sort of tools we can use. But then how do we actually implement it? It's all well and good us wanting to do this, but how do we go about doing it? If it's centralized logging, it's relatively easy. Install FileBeat, ship the logs off to somewhere, and that's pretty straightforward. But for the rest of it, how do we actually get this all tied together? So, if we want to do this, we want something that's, not bespoke to a particular vendor. So I've said there's so many platforms. you don't want to have to update your application to every individual vendor. You don't want to have to explicitly configure shipping stuff off to Splunk, install new relics extension, and get that going. You don't want to do that. Like anything in programming, we want to abstract it out and make it as generic as possible for our application. We also want to do it with minimal effort. We don't want to be adding lots of code. It's particularly not lots of code that's just helping us measure performance. It's a lot of work, it's a lot of overhead. So, and we want something that's a standard that's adopted across the industry, because we don't want to head down a route where one person is, one bit of software is there and we're using that, and it becomes a dead end in a few years. We want something standard that everyone supports or is widely adopted. And I've got a suggestion for that, which is OpenTelemetry. So, OpenTelemetry is an open source project. It was a combination of 2 other projects that came together, and it's supported by the Cloud Native Computing Foundation. So it's one of their incubating projects. Other projects of theirs is basically everything you've ever heard of for cloud-based systems. They support everything. It's vendor neutral. It's supported by pretty much every vendor out there. So if you want to use Splunk, it's supported. New Relic, supported Datadog, Honeycomb, everyone. You want to use Prometheus, you want to use Grafana, you want to use InfluxDB, it's all supported. It's all just well supported as part of it. And zero code is required if you want to really quickly get implementing it. And I mean literally zero code in your application. And I'll show you that in a bit later. And they've got that also for multiple languages, not just PHP. So we'll do a demo of that later and show you how cool that is. So how does it work? So in your application, you can either configure it to send the data directly to your backend provider, so Jaeger, Datadog, Honeycomb, or the better way to do it is to use what's called the OpenTelemetry collector. So it's a service that you run alongside your application. If your application is running natively, you can run it as an agent in the operating system, or you can run it as a Docker container alongside it. It can even be remote if you need to. And one of the reasons for doing this is, firstly, in this collector, we can specify multiple backends to send the data to. So you're not limited to just using one provider. You can send everything to as many different providers as you like. It also supports various pipelining of the data, transformations of that data, and it's got a lot more configuration on it. So let's go in a bit more on that one. So I mentioned runs as an agent. It's defined, the config is defined in YAML. It's pretty straightforward. It's got all different extensions and filters that you can put in there. And I say you can define the pipelines. So typical processes you'll tend to use, for example, would be to batch the data up. So you're not making individual requests of sending this data up, you're batching it into huge batches and sending it. It will also handle retries. So if you're sending directly from your application has to know that if it can't contact where it's sending the data, it will have to retry it. And that's extra work that you might have to do. Whereas the collector takes care of that. Your application sends it to this collector using a protocol it uses, which is generally running locally. The collector can take care of everything around batching it, pipelining it, transforming it. The collector can remove secrets or anything like that. So if you think you may accidentally end up logging credit card numbers, you can configure a regex filter on it to go, if you detect anything that's 16 numbers, mask it out and filter it. You can do the same potentially with IP addresses and that kind of thing if you know you want to make sure PII is not sent elsewhere. So the collector is really cool, and it's a really nice way of doing it, and it's how I'd recommend anyone goes about doing this, and I'll demo that in a bit. So I mentioned it was zero code. So to use it with PHP, it consists of 3 main things to do the zero code implementation. One, there's a PHP extension. The PHP extension is available on Peckle, it's easy to install. The next thing is composer packages. So because of how the extension works, there's just packages on packages that you can pull in for most frameworks, libraries, anything that you're generally doing where you might want this. There's probably already a library written. And if not, they're actually pretty easy to write. And finally, you can just configure it with about 4 environment variables. And then that's all you need to do to your application. Add an extension, pull in some packages, and add some environment variables. So this extension is based on ZendObserver, which is a way of observing and hooking into PHP code. Xdebug uses part of this, for instance. And talking to Derek behind Xdebug, he was saying this is a really efficient way of doing it, and it's a great way to do it. So what this means is, when you write your library to monitor your application, or you pull down a package that someone else is using to do it, it doesn't have to modify your application at all. There are ones out there that will, for example, for any HTTP client like Guzzle, it will just literally bind to the functions. So when they're invoked, it will immediately start monitoring that without modifying any of your code. And it's really easy to install. So you can install it through Packle, you can use the PHP extension installer if you're in Docker, or you can use the newly released Pi project to install it. And it's just a nice simple extension, easy to get going with. So the composer packages. So the composer packages, this is where people have written software that hooks in using these hooks from the extension. And it's just got support for everything. There's an example there of 3 of them. So you've got the SDK, which you need as a default. Then you've got the auto one for Laravel. Hooks into everything you could ever want in Laravel. You don't have to change any logging options. It will hook into Laravel's events, jobs, any of the scheduler commands, and it will just do it all for you. The other one there, for example, is auto PSR 15. So if you're using something like Mezio or something, where it's sort of middleware based, it will also hook into that. So the packages make it really easy to just get going with this immediately. And finally, the environment variables. So we set them using .env or Docker run or whatever you're doing for environment variables. You just put those in, and those 4 are enough to get it going. So you enable the auto telemetry, you give us your application a name, you specify where to send the data to, and you can specify the protocol. And it supports a few protocols. So I've used HTTP/JSON here as it's the easiest, but in production or something like that, you would probably use gRPC or protobuf, which would require some more PHP extensions, but they're fairly easy to install. But to get going with this, it's just going to be using HTTP/JSON. So let's take a look and see how this goes. So let's go for a demo. Cool. Excellent. So we've got a simple application here that just displays some quotes. You refresh it, you get a random quote. It's a pretty simple PHP application. It's a Laravel application, and it's really basic. Doesn't really do anything. So what do we need to do to add this in? So let's just make things a bit larger. Can I make this larger? Sorry about this. Should have thought about this. Let's just do this then. Cool. Sorry. I hate live demos. Cool. So, first we've said we need to update the Docker file, so we need to add this extension. So this runs in Docker, so let's add the extension to it. So, here's one I prepared earlier. We're just going to literally add one line to our Docker file. So if we go here, we go to our Docker file, and let's see, can I zoom this in? Of course I can't. Cool. There we go. So we're just going to install a new extension here.
You're showing the slides.
Still showing slides? Thank you. I'm sorry. Cool. Show my entire screen. Okay, let's just close the slides. Cool. Okay. So we're just going to add this line here and just install our extension. So install PHP extension, OpenTelemetry. So let's just run this. So Docker build, and we'll build the application, which is quotes, and we'll build the composer. Sorry. Cool. So this is just going to build, and it's built those because the layer's already there. So now we have those packages installed. So the next thing we've got is we need to add some packages. So we're going to add the SDK, we're going to add an exporter, and we're going to add the auto package for Laravel. So let's let's add those. So here we can see we're downloading some, and we want to allow plugins. Cool. There we go, our packages are now installed. So the final thing we'll do is we'll just add the environment variables. So these are the environment variables we're using. It's similar to the ones I showed in the presentation. So in our application, I expanded everything, didn't I? Cool. Okay, so let's just add these in. Okay, so that's now in our application. Just to be sure, we'll just do a docker compose restart quotes. Okay, and there we are. Open extension must be loaded. Thanks. There we go. Restart it to pick up the new extension. So our application is running just as it was before. So how do we know it's doing anything? So we now need to run the collector. Our application is updated, let's run the collector. So the collector, it's just going to be a Docker, extra Docker image we're going to run alongside. So we'll just drop this into our Docker compose. And this uses the OpenTelemetry collector contrib image. So this is one that OpenTelemetry provide that has support for basically everything you want. And if you want something a bit smaller, you can actually build your own, and they've got instructions on how to build one that's smaller using just what you need. It's going to need a config file. In this case, it's called collector.yml by default. So we'll take the example from this project. Cool. So this is our config file, and let's just resize it a bit. So we can see we specified our receivers. So we've said we've got receivers here on OTLP, which is OpenTelemetry's protocol, and we support HTTP, and we support gRPC. We've only got the batch processor running in default, and the only exporter we've defined at the moment is debug. So the debug exporter just prints it to the console. And here's where we define our pipelines. So for traces, we can see we receive it through OTLP, we run it through the batch processor, and we export it as debug. And it's the same for metrics and logs. So let's do a... So now our collector's running, and we'll do... So now we can see our collector's running, and it's beginning, and it's ready to process data. So let's send some data to it. So we refresh our application, and we should hopefully start to see some debug data coming through. And this is why I hate live demos. Okay. Let's see. Okay. Sorry about this. Collector 4318, PHP yeah, it should be received. Okay, let's move on and just see if the next bit works, just in case.
Does Docker see the YAML file?
Yes, it can, yeah. Thanks for checking that though.
Right.
No, it's /collector.yml. Yeah, collector.yml, yeah. So it's definitely picked that up. It's probably going to be okay. Let's hope it's okay. Okay, so we're going to use Honeycomb to demo this. So I've already grabbed the config from Honeycomb and an API key just for this talk. So let's go drop this in. So in our collector YAML, we can now define another exporter here. And we'll indent it a bit. Cool. And then we just need to tell it to send the data through to this output. At the moment, we've not changed our application. We've just set some environment variables and installed some packages. So, now I've done this, we'll restart the collector. Cool. So, hopefully now the collector will send the data out to Honeycomb. So let's see if this appears. Are we going to see any data? No. I hate live demos. I'm sorry about this. Right. Okay. Compose. Fine. Okay. Cool. That's there, tell PHP able to load. Okay, that should do. Cool. Okay. Bizarre. Let's check our Docker Compose. Now let's see if this works. Okay, can we have some data, please? It's not gone as well as I'd like. Okay, so we are actually seeing stuff, yeah. Let's see, is that hotel component kind, traces? So are we seeing anything? There we are, finally. Sorry about that. So, it's now sending the data through. The answer is, I had to actually have it running as in the environment. So, here we can see we've got 6 total spans, and we can see what these are. So if we go look at these, we can see our traces. So traces consist of the trace and then individual spans within them. So what we can do is we can now look at this trace. So we see the waterfall that we saw, and we can see here that it's auto-instrumented looking into the database queries. So we can now see exactly how much of our time was spent doing a database query. So we can see 2.6 milliseconds to query this. You also get lots of information about the request. So in this case, we've got our client address, we've got the code that was executed, the duration of the entire request, the HTTP method, everything like that. So that's great, that's absolutely amazing. The other thing we can do is we can also get any error logs and stuff. So I've got an endpoint on here, error, and if we go there, we get an unexpected error. The code itself is just throwing an exception, but we can come through to here, we can go back to our homepage here, and it now knows there's an error. So we can now go look and see what this error was, and we can then explore the data. We can see the trace that through the error. We can see that it was a get/error. We've got all that context information we had before. We've got the client address. We've got all this information. And this is where value comes in, is we get to see all this. We can see, when the exception happened. So this is where you get the value from it, is you can then see the entire stack trace of it coming through. But you get all this information, and it will also show up in the logs. So if we go and look at the logs, we can look at the logs, we can see we've got some logging that happened, and if we just look at the actual data itself, so we go explore data, and we collapse that, and we can add in the log messages. So if we, log lines, we can expand log lines, we can see all the information that came through for them, and we can actually get from here back to the individual traces that triggered them. So it's really useful. So here we are. We add the body of it. We can see our logs. We can see the exact traces that called them. And we add it back to the application. Aside from me messing around with Docker, we haven't modified our application at all, and we've got all this. and we can just install more packages and more libraries. And I mentioned variable packages. So this is just searching for the tag on Packagist for OpenTelemetry. And we've got ones that will automatically do for Symfony, Monolog, Slim, PSR3, so we'll just hook into any generic logger that's out there. PSR18, so HTTP clients. So if you're using Guzzle, it will just telemetry that for you. And the great thing with the PSR18 one is it will attach trace IDs in the request headers, and then anything downstream can pick those up and use them. And that's all done for you. There's specific ones for Guzzle. There's just lots for everything you could possibly want is probably there. So that's really how easy it is to implement, how easy it is to get going with it. So if I just go back to the presentation, and we'll keep it where we left off, and go to our live demo. Cool. Okay, so where do you go further from here? So just showing how easy it is to get going. So that's auto-instrumentation. You can do manual instrumentation. It takes a bit of setup. They've got some nice builder methods that you can use in classes to help you. That's great. You don't necessarily need to get started. Maybe only do that when you want to. It's got great support for attributes. So there's one thing we've added. You can just add attributes to your methods and classes, and it will actually pick up on that and just automatically create the spans for you. So even with auto-instrumentation, you don't have to write much code, just add a few attributes. You can also just write your own packages for those hooks. It's pretty simple. You specify which function and classes you want to hook, and you've got a pre-method and a post method. And you can do your setup in there. It takes about 10 lines of code to hook something. And then metrics. So I didn't really cover how to produce metrics, because Laravel doesn't really have a nice way built in to export metrics. But there's plugins that, there's packages that will add sort of Prometheus support to it. And you can expose a Prometheus endpoint. And OpenTelemetry, you can just configure as one of its inputs a Prometheus scraper, and you can define everything you would in Prometheus. So if you output Prometheus metrics, you can just have OpenTelemetry collector collect those and send those on elsewhere, which may be to another Prometheus instance. So I mentioned the attribute-based hooks. So it's really, really simple. You just literally add, with span, and that's it. This function would now show up as its own individual span within your trace. You can extend this a bit further and actually add attributes to arguments to your functions, and it will track those through as well. So another thing you may want to do is sampling. So telemetry can generate a lot of data. If you've got a busy application, you don't necessarily want to log everything. You probably only want about 5% of the data plus any errors that have occurred. So it's got options built in to do it. So firstly, as part of the extension, you can specify various different sampling rates. So you can say sample based on a trace ID, and I only want 20% of it. And that's simple to do. But if you want to do more complex sampling, you can edit it in the collector. The collector has full sampling built in, and there you can do all kinds of stuff, like any attributes that you've attached to a request in your application. You can choose whether to sample based on that. You can maybe say these particular endpoints you don't want to sample at all, or you want to sample only 1% of a particular path. You can say that any of these users you might want to sample all the requests for. So if you've got some VIP users, you could tag them as such. Your application could go, always trace this one. So you've got lots of options there that you can configure, which I'm not going to go into. So extra resources for this. The OpenTelemetry documentation is really good, extensive. They've got examples there for PHP plus Java, Go, any language you could probably want. They've got auto-instrumentation for about 5 or 6 languages. They've also got the list of all the vendors they support. So everyone who's supported by them, and it's really useful. Installing extensions. The PHP installer for extensions came out this year, supported by PHP Foundation. It's a really good way to install and manage extensions on your local PC. If you ever had the nightmare of trying to download them with Peckle and that kind of thing, it just takes care of that for you. There's a link to the slides. The slides and this code is in there. Feel free to take a look at it. Feel free to submit pull requests and criticize the code. And there's a link to the slides there as well. Thank you all very much for the time, and There's where you can find me on different things, and I hang around the Rove Discord. If you're not part of that Discord, join it. They're an awesome group of people. Okay. Any questions? Yeah, Dave.
A question about the span. So you had an example, I think I probably missed it. Remind me what a span was again and why you had it on an attribute.
Yeah, of course. So, should have gone into more depth on this. So within an individual trace, so a trace represents a request. You've got individual spans, and they represent things that are done within that request. So if we go look at the waterfall diagram way back, let's see here. So here we can see these are the individual spans within. So sort of checkout service, cart service, and we can see the individual, how much time they took. So if you've seen waterfall diagrams like this, for example, in browser console and that kind of thing, these are individual spans. So spans denote operations happening within a trace. So they're individual things you may want to measure.
So entry and exit from a method?
Entry and exit from method is a perfect one, yeah. So the example I gave of doing a custom span on a function. Say you've got something that goes and calls an external API and maybe does a bit of processing. You could stick that in, you could do a span around that, and then you'd know exactly how long it takes to process this information. Yeah. Yep.
You've spoken about this in the context of requests. Presumably it works just as well if you've got like a job queue running stuff.
Yeah, absolutely. So Laravel auto instrumentation, it picks up on commands. So if I was to write a command and run it, it would absolutely trace that. And instead of just being a HTTP post, it would then be some other source for it. It does. It picks up on jobs being processed. It picks up on command line tools. Absolutely does. Anything that's run with PHP with it enabled, as long as it's got auto instrumentation to know to start creating a trace, it will work. Yeah, that's enough question. Yeah.
Are you familiar with Sentry for capturing errors?
Yes. Yeah.
We've got Sentry, and I was looking at OpenTelemetry.
Yeah.
And Sentry has the concept of traces and spans within it, and you can put code in there to keep track of those.
Yeah.
But it didn't seem to be integrated with OpenTelemetry.
It does support OpenTelemetry.
Does it?
It does, yeah. Let's just stop this presentation and show, and we'll just go to the OpenTelemetry website. So, OpenTelemetry.io. So this is the OpenTelemetry website, and we go to the ecosystem, and we can see the vendors who natively support it. So in here, Sentry do support it here. Let's see, what's this column? Yeah, commercial. So to do it, you would probably just specify exporter of Sentry, and they would have the settings on there for you to put in. Sentry does support OpenTelemetry, and if I was sending stuff to Sentry, I would probably use OpenTelemetry to do it and then send it via the collector, just because it's flexible that way. Yeah.
Question about sort of like the privacy of it. Obviously, you're sharing information with potentially an external service. Does it sort of wrap things up automatically?
Yeah. So that's dependent on the service you're using. So it will support. Obviously, it'll send it over TLS if you want to. It will use authentication, as you've seen with the Honeycomb integration there. It was using HTTPS, and it was specifying an API key to be able to submit it. You can also use certificates, and you can also use client certificates as well. You can use OAuth2, OpenID, all kinds of different authentication mechanisms are built in if you want to use them. So yeah.
Does it also allow you to like configure what you're sending as well? Like so you have like database queries and things?
Yeah, absolutely. So the auto instrumentation by default will do everything, but you can disable certain parts of that. It does have configuration options to disable some of the things that it's sending, and also you can not install some of the packages. So the Laravel Auto one is designed to send as much of the Laravel data as possible that's relevant. But you could just install a basic one that works on sort of PSR15 requests, which would probably pick up Laravel's PSR15 sort of middleware basically kicking off and start the request, but it wouldn't then do the database. Any other? Yeah?
Yeah. I know most of the vendors do like mostly the same stuff. Do you have a preference?
I'm having this debate at work at the moment. I like Honeycomb because I like a lot of how they're trying to drive observability, and that's a personal preference. Datadog are great. They're adding a bit too much AI stuff in there for my liking. And at work, we're probably using AWS and X-Ray and CloudWatch. Yeah, my preference would be Honeycomb personally. I did really like Sentry. Like Sentry is, yeah, what I liked before. So, yeah, don't have too much of a preference. Probably one of those, but that's personal. You know, assess them. But the great thing is, if you're using a collector, you want to try one, just stick it into the exporters. You don't have to change your code. You just add it in, try it. That's one of the benefits. Yeah. Yeah.
Is there much performance overhead to all this?
No, very, very minimal. I was worried about this initially as well. So I spoke to Derek Revens, who makes Xdebug and works on PHP Core, and knows the Zen observer pattern well and how it works. And he was saying it's really, really efficient. It's not something you need to worry about. So the overhead isn't high. You don't worry about it. It's basically the answer I got when I asked Derek about it in Verona this year.
Is it capable of passing metrics on its own, like resource usage?
Yes, it does. Yes, it's got its own actual internal metrics that it can export, and you can just configure those. So if we go to the docs, again, it's fully docked into the docs, so you can go for the collector itself, internal telemetry, and you can specify its own internal metrics, and it can set its own Prometheus outputs and all sorts. So yeah, you can absolutely measure the collector itself. Yeah. Cool. Anything? Okay. In which case, thank you all very much. Thank you for bearing with me.